हेलो। लेट्स स्टार्ट। आज हम पढ़ेंगे हीप और उसके कुछ क्वेश्चंस हुए तो वो सॉल्व करेंगे। तो पहले हीप होता क्या है? कंप्लीट बाइनरी ट्री। कंप्लीट बाइनरी ट्री क्या होता था? Which all levels are completely filled except possibly the lowest one, which is filled from the left. Okay. allowing quick access to maximum और मिनिमम एलिमेंट, मतलब इसका मकसद है अभी नेक्स्ट मैक्सिमम कौन सा है, नेक्स्ट मिनिमम कौन सा है, वो फाइंड आउट करने के लिए। मैंने अपना मिनिमम वाला एलिमेंट लेफ्ट टॉप पे होगा। हीप में ऊपर जो नोड है दैट विल बी ग्रेटर देन, that will be less than all nodes below it. Key at the root must be smallest among all the keys, and this property must hold true recursively. Binary heap को traversing is used to achieve array representation is level order traversal. Operations on heap. Get min मतलब रूट रिटर्न कर दो. एक्सट्रैक्ट min मतलब टू निकाल के अभी नेक्स्ट कौन सा होगा, हिपिफाई करना होगा. डिक्रीज की 35 25 बचा. 50 को 5 बचा दिया, 55 किया तो 5 उधर है, 15 और 40 है, 55 के 5 उधर है, 20. इंसर्ट इसमें तो 1 को लास्ट में ऐड किया, इसको 85 किया, 10 1 100 को टॉप पे रखा, 55 लिया.
Okay, so what I'll do, form of an array only, like internally it is stored in an array. So index I is equal to 2 into I, 2 3 4 only like once every level. Eight. At 8 will go over, let's say, no, 7 will put in like an array like this, but this is how we are visualizing it. So I'm writing both the ways so you understand. But now there's a violation. Because it's a min heap, minimum item should be at the very top. So we are going to check the item that we have just inserted, check its parent. Is it smaller than the parent? Yes, it is. Okay, swap. Let's say I keep inserting. Let's say I will insert, so it will be swapped. 10, 11, 12, 10. It's fine. Condition is maintained. They may not be 13. This thing is important. First item should be minimum. 13 here. And let's say after that I insert 5. So let me just write this down. 1, 2, 3 index, 4th index, 5 index, 6 index, 7 index, 8 index. Now I insert 5. I insert 5 and it's like, hey, you have just inserted 5, index number 9. That is violating the condition. Violating the condition. So please remember one thing. Here I know that for every node, value of every node is less than equal to all its children. Make sense? So value of 10 is going to be less than, has to be less than all the children. value of 9 has to be less than all of its children. Value of 8 has to be less than all of its children. Right now, because of 5, that is violated, but in general. So, I know, like, Kunal, do you have to check it? No. Then 5, 10. Why is 5 going to be less than 13? Because 13 is greater than 10. Makes sense. So I checked, like, okay, I added 5 over here first at index number 9. I'm going to check, hey, is 5 less than 10? Yes, it is. Okay, swap. Now, do I need to check whether 5 is less than 13 or not? No, because I know automatically all the number breaking any law greater than 5. Okay, again, swap. Once every level, only like once every level, I started like this, and this, and this. So, one every level. And total, how many levels we have? Log of n. So, complexity is O of log n to insert an element. Easy. Sounds good? That's how you insert elements in a heap. Very simple. Try running it, pen and paper. Is the tree videos tutorials. I would say pause this video and think about it. Question is, if you remove an item, so you all understand how to insert an item? But let's say we remove the item in the min heap. So obviously the first item, this will be removed. Now, how do you rebalance this tree? How do you make sure that the next smallest item comes on top? How do you make sure we do that? Pause this and think about it. Okay. So you know how when we inserted, we did like from the bottom to the top. This way we will do opposite. So just what you have to do is take the last element, because that I can get very easily because it's just at the last, and put it at the 0th index or the first index, whatever the first index is. Remove. Now search for downwards. So start from here. Check what is smaller, left or right. You can get left easily, right easily. 2 into I and 2 into I plus 1. Okay. Initially I is equal to, let's say, 1. You can take I 0 as well. Maybe when I code, I will take array from 0. Not a problem. That will be simple. Very simple. What will be the values then? If you take array, like what will be the parent? Parent will be, instead of index divided by 2, index minus 1 divided by 2. Left will be index into 2 plus 1. What will be the parent? Parent will be, instead of index divided by 2, index minus 1 divided by 2. Left will be like what will be the, very simple. What will be the values then? If you take array, like what will be the parent? Parent will be, instead of index divided by 2, index minus 1 divided by 2. Left will be index into 2 plus 1. And right will be index into 2 plus 2. Whatever, you can take from index number 1 also. Okay. So I'll check. Left is smaller or right is smaller? Left is smaller, swap it. Now from again, check here. Do I have to check it from here now for 9 as well? No, I do not. I don't have to check with 9. Okay, because of these conditions. Same reason as I gave previously. Similarly, now for 10, is left smaller or right smaller? Left is smaller, again swap. This will also be, this will be 7, this will be 10, this will be 8. Now left and right, there is no right, so I will not check, otherwise it will be exception. Right, so there is no right. Left, is left smaller than the current value that I'm checking? No, it's not. Okay, program over, that's done. That's it. This is also doing the same thing, taking it only one over done. Simple, I just told you everything. Told you all the formulas. Try coding it from, let's say if we store it from 0th index itself. And instead of using array to make your life simpler, use array list. Array list is fine, use array list. And very simple, yeah. So log and insertion, log and deletion, we checked that. We saw the structure, how it's represented. We saw how the tree is represented using these formulas. Or you can saw the structure, how it's represented. We saw how the tree is represented using these formulas. Or you can start from 0th index as well. You can calculate formulas for that. I'll write it web page as well. So the link to the code is in the description. Is anything else remaining? No, nothing else is remaining. Now it's just simple coding part. Coding part is simple. Most of my videos, the coding part is just 5 minutes. Simple. Okay, after this we will do heap sort and priority queue in this video only. Heap sort is nothing. Okay, heap sort is easy. I'll tell you right now. So it's so simple. Every time you are removing an item, you know that in mini heap you are removing the smallest item. Okay, if I remove an item from here right now, it will remove 7, then it will remove 8, then it will remove 9, then it will remove 10, then 11, then 12, then 13, then 14. So keep removing items from the heap and just store it in an array list or a list, whatever you want to do. So n items if you remove, it will take n into log n time. N log n heap. That's heap sort. Heap sort is easy. Nothing in heap sort. Okay. I don't know what you want me to tell you. I feel like it, when I'm teaching, because I've taught in person as well. And like it's that simple. People get confused. They're like, are you sure, Kunal Bhaiya? Are you sure that it's just this and nothing else needs to be done? Public create. Easy. All right. New file. I want to call it heap.java. And that's it. Class heap. I'm going to zoom in a little bit. Okay, what do we do? This is how we do this. What do? We need array. So import java.util.arraylist, and class heap is something we have over here. Okay, not a problem. What I'm going to do is that I'm going to make this of type like I'm going to make it generic. Okay, so for example, you know what generics are, right? So if I say something like in the heap here, if I say something like, let's say heap of what? Heap of integer. Heap is equal to new heap. We all know what this thing is, the generics. We have done it in object-oriented programming. So here I will have to then make this also in terms of generics. There you go. Gonna say type T extends comparable. We all know how this thing works because we have done object-oriented programming. If you have not, please watch object-oriented programming playlist. This is how we can compare two objects. This is why I'm extending it with comparable, so I can compare two objects. Please understand. Okay. All right. That looks fine. Okay. Now heap will have an array. I'll just make an array list. Private array list of type T list constructor. Done. What now? Okay, but since we're going to swap a lot of elements, let's say this is an array list. I need to swap two indices, so I'll just create a swap function to make my life easy. Private, not returning anything. First index, second index. Temp is equal to list dot get first list dot should be curly braces. Okay, then I can say list dot set. You all know how to swap two numbers, right? In an array, two indices. Please. If you don't know how to swap two indices in an array list, how can you clear your interviews? Please. And then list dot set. It is going to be very shameful for you if I explain to you how this function is working. Question is swap two indices in an array list. It is going to be shameful if in this example I have if root is equal to I is equal to 1, if then 3 into 2 plus 1, 1 into 2 plus 1, 0 into, think about it, what did we do for the parent? Get the parent, int p is equal to parent of this index, but also if you are at the base condition, so if you're at the 0th index, then it is over. Then just return, nothing else needs to be done. Start checking for the parent. So if I added stuff over here, I'll check for the parent. Is parent, greater than the current value? So current item dot compare to parent should be less than 0. Means if the current item is smaller than parent, then swap. So if list dot get index, if item at this index compare to list dot get parent, means if the 0th index and this temp will
is our Netlify is doing. Let right the
Now let's look at how to remove elements. Okay, heaps is true. You can put, obviously the first item, this will be removed. Now how do you rebalance this tree? How do you make sure that the next smallest item comes on top? How do you make sure we do that? Pause this and think about it. Okay, so you know how when we inserted we just did like from the bottom to the up, this way we will do opposite. So just what you have to do is take the last element, because that I can get very easily because it's just at the last, and put it at the 0th index or the first index, whatever the first index is.
मुझे क्या करना है फंक्शन to delete a key at ith index. लास्ट वाले को इधर रख दिया, कर दिया। Bro, this seems to be right. Why is it not?
It's saved.
Areas of a quiz like some combinations can be from the using getting listed at most ones. Attempt to optimize some combinations and increasing model. complete runtime level. Memory limit exceeded. I have to use max heap somehow. Once I'm sorted, I will take this frame and push it here. Now यही बार करना है, पहले मैं सॉल्व कर लेता हूँ। What will I do? ब्रो, व्हाट अ सॉल्यूशन भाई, क्या ही बना के दे दिया इसने ये। वो बहुत, I couldn't have written this. I couldn't have. This is so fucking smart.
What's up, guys? Welcome back to the channel. In this particular problem is an maximum here. I have according to the we have and to be equal to 2, right? Because so with combine this out of the maximum output for. Let's talk about and see guys, after looking at the problem explanation, the first approach that will come to your mind is quite similar to this one. We can try out every possible combination, right? So we can try out this 3 with this 1 and 4, then this 2 with this 1 and 4. Like this we can try out every combination, and these are the result of combinations, right? After this we can simply find k largest values. How we can find? So guys, whenever it comes to finding k largest values or k smallest values or the kth largest element or the kth smallest element, then we always use a priority queue. Priority queue, what is the reason behind this? So priority queue basically helps us in getting largest or smallest element in just log n time. So this is called an optimization, guys, right? So let me write pros that I have is here, trying out every possible combination, right? Guys, the time count is going to take log n time, right? So the total time complexity here is going to be O of n square log n. So always keep in mind, guys, whenever we try out every possible combination or every possible path, then the approach is known as brute force approach. After this, once we have got the element in priority queue, then we can try out this possible loop. This loop is basically going to give me k element, right? It is going to run k times, or if our queue priority queue becomes empty, so it is going to get every possible largest element from the priority queue each time and going to add that to the answer. So this is the first approach, guys, approach that we have right now, which is the we are doing in this piece. And somewhere in the middle I will tell you what optimization we are doing in this particular approach. First of all, see here, we are given this particular example, right? First of all, what we can do is we can simply sort these two arrays, guys. And there's a reason why I'm sorting these arrays. First of all, let me write the values. I have 2, 3, and 6 for the array A. And then for array B, I have 1, 4, and element is just element, and so on, right? So guys, we know that this particular element is going to be the largest element. So what we can do is we can simply try out combining every possible value in the array A with this particular value, because we know this is the largest value. So when we do this, what we will get is we will get 2 plus 5, first 2 plus 5, which is 7, then we will get 3 plus 5, which is 8, then we will get 6 plus 5, which is nothing but 11, right? And guys, while writing them, always remember one thing, that we are combining these elements with the last index, which is the second index for this array, right? 0, 1, 2. After this, guys, we have to store these values in the priority queue, because priority queue is going to give me a combination. So let me write the pseudo code in parallel as well, guys. So first of all, I am going to sort the arrays, right? A dot sort, and then I will do B dot sort. After sorting the arrays, I will create a priority queue. Right, sir. So why I need a list, guys? You can see again, whenever our we are given a value k. So guys, we have to is also given here as 2. So guys, I will simply make a list as well. Now first task is to store the combination of all these values with this particular value in D, right? So I will say that okay, for like pq.add simply sum, right? So I will say that a of I plus b of this element is constant, which is last element, right? B of n minus 1. Along with this, guys, I want to store this index as well, so that it doesn't get lost. Like I'm going to store some like this, which is 7 comma 2, then I have 8 comma 2, then I have 11 comma 2, where the first value is the sum and second value is the index of element b, right, of array b. So I'm going to store the index as well, which is currently n minus 1, right? So guys, this is how I can store these values like this. So this is the visual representation of the priority queue. After this, we can simply get the values from priority queue, because our task is to get k values, right? So I'll say that okay, while my pq is not empty, pq is not empty, and our k values are not done yet, right? K minus 1 is greater than 0. So this is something that I will do. And inside this, guys, I will extract pair one by one. So I will first get this pair, because this pair has a maximum sum, right? And this is how priority queue works, guys. So I'll say that okay, give me the maximum pair. So I'll say that okay, pair is simply equal to pq dot pole, right? Pq dot pole. And this pair contains two values. The first one is sum, so sum equals to pair dot sum. And then we have like okay, index equal to pair dot index, right? Guys, I'm just writing the pseudocode. This is not the exact implementation, so it doesn't get confused with pseudocode and the implementation, right? I will definitely show the implementation in every possible language. So for now, just see here, guys. Now you will raise a question. You will say that, hey, you are combining this particular like all the numbers from array A with this number only, right? So why you are not trying out the combining these numbers with this particular number? Because there is a possibility that I can get maximum sum by combining these elements with this number as well, right? So there's a possibility. So why I'm not trying out? Let me explain, guys. I will definitely try out combining these number with this particular element as well. But before that, always remember one thing, that if this is the maximum number, so these two are the sum of these two numbers, because this is the maximum of array 1 and this is the maximum of array 2. So the sum of these two is going to be the maximum, right? I will only add more values whenever required. So if not required, I will not add. Let me explain how it works. So first of all, I'm going to pull one value, and now I know that sum is going to be the maximum. So I'll say that answer dot add sum, right? Answer dot add sum. And guys, now I will get in my answer array, I will get 11 as the answer. And now this value is removed from the priority queue, right? After this, guys, now you can see that I have the index as 2, right? So I will try out combining every value with 2 minus 1, which is the previous index of this particular index. So 2 minus 1 is 1. So now I will try out combining all values with this particular value, right? So how I can do this? First of all, I'll simply do one thing. I'm talking about this particular combination, right? So when I talk about this particular combination, guys, so I will get this particular a of I. So I have 6 plus 5. So if I do minus 5, then I can simply get 6. This means that if I have sum and if I do minus b of index, then I can simply get the value of a, right? After this, I can simply add b of index minus 1. So what this will do is, this will first get the value 6 and then add 4 to that particular value, right? So when I do this, I will first check if my index minus 1 is greater than equal to 0, right? Because index minus 1 can go out of bound as well when it becomes minus 1. So guys, I have to make sure that this condition is true. After this, I'll say that pq.add, what value I have to add? I have to add sum minus b of index, then I will do okay plus b of index minus 1. After this, guys, see, pq always stores up here. Pq stores up here. You can see that pq stores up here. So now I will
So hey everyone, welcome back to the channel. In this video, we will be solving the problem maximum sum combination. So let's read the problem statement out. So we are given two integer array a and b of size n. A sum combination is made by adding one element from possible sum combinations. Okay, so we are given two arrays and we have to return the maximum k valid combinations, and we need to return the output array in a non-increasing order. Okay, so so out of all these four combinations, 1, 4, 2, and 3, and my b is 2, 5, 1, and 6. Now, how can we get the maximum combination sums possible? So basically, you can iterate on this array, and for one, you can iterate on all of these elements of the array, right? And what we can do, we can generate all the sums. So 1 plus 2 is going to be 3, 5 plus 1 is going to be 6, 1 plus 1 is going to be 2, and 1 plus 6 is going to be 7. Similarly, you can generate all the sums possible for each of the numbers, right? And you can store that in a vector kind of thing, and you can sort it out, right? So let's say I make vector of int answer and store, so whatever be the max 0 to k minus 1 of this answer vector will be storing the maximum sums approach. Why? Because we will be using so total sum possibles will also be going to be can solve our problem. Like if you observe our problem statement, in the problem it is written that we need to find k valid sum combinations. So whenever it is written like k valid sum combinations or k combinations possible, try to think of priority queues, because generally in priority queue problems this letter. So let's say my array is like this, 3, 2, and b is like this, 1, 4. Now we can sort both the arrays. So let's say we sort a becomes 2, 3, b becomes 1. The maximum element from array a, and b will indicate the maximum element from array b, right? So we can take both of them and we can make a priority queue, and we can push 7, 1, 1 into our priority queue. Okay? And we will also be requiring a set. Why? We will see in some time. Okay? So since 1, 1 we have already visited, so we will be putting that into our set. Now we will be doing this step for the first time. Okay, now we will be running our while loop for k times, because we need the valid k combinations possible. Okay, we can make our operations for k times only, no need to do operations further. And the next time what we will be doing, we will be taking this out of our priority queue, and we know 7 is going to be our maximum sum. So can't we store that 7 into our answer vector, right? So let's store 7 into our answer vector. Now the next time 1, 1 we take this index and we will try to make a valid combinations out of these two, right? So why we are doing this, I will let you know in some time. So see, 2, 3 था, 1, 4 था. 3, 4 से हमने already बना लिया, and 2, 4, right? We use this in order to make our next combinations. ठीक है? Why? Let's say our array is like this, 3, 3, 4 and 1, 2, 9, right? So first of all, we took this 2. Now the next time it might also happen, like these two can make the maximum combination possible for the next time, or these two can make the maximum combination possible, right? Every time this will not be the case, like we will be trying the elements index wise. That might be possible. 3, 9 is the next greater sum, as you can see, 13, 12, right? So we will try to make a combinations from 9, 3 as well. right? So that's why we will be trying to make a combination from 2 comma 3. So basically, let's say my index is x comma y. What we will be doing, we will be trying to make a combination from index x comma y minus 1 or x minus 1 comma y, right? So diagonally. So next time, let's make a combination out of, let's say 3 comma 4 we already took. So let's make a combination of 4 comma 2. So next time, let's say make a combination for 4 comma 2. The index for this is going to be 0. The index for this is going to be 1, right? Also, since 0 comma 1 was not present in our set, that's why we have made that. Otherwise, we will not be making that, because it might be possible like the next time, basically, let's say my array is a comma b comma c and d comma e comma f, right? It might be possible like when we popped out e, we made a combination with a, right? Basically, second maximum sum. Why? Because parity queue stores the answer vector and we can return. We will be sorting both the arrays. We will be taking a parity queue of type pair of intent. Basically, this will store the sum and this will store the indexes from both the arrays, right? Now, set of pair of int comma is basically we are doing an optimization. So basically here we will be pushing back the last elements of both the vectors because it will be maximum among them. So that is going to be the sum. This is our indexes and we can store that indexes into our set. Now, what will be the first element? That is going to be pq.top. But pq.top will be a type of pair of int comma pair of int. Now the sum we can easily get using the first element of
I think that's all. Bye.